To help us with the next part of the lesson, I would like you to create a little summary of the domains that we've talked about so far. So I just made it at the bottom of this page right here. So I sectioned off this last part, I called it domains, and I have the 4 domains that we've learned about so far. So sine, we restricted the domain from negative pi halves to pi halves, quadrant 1 and negative quadrant 4. Cosine, we restricted the domain from 0 to pi, quadrant 1 and quadrant 2. Now, I also noted that the domain of the arcsine graph went from negative 1 to 1, and the domain of the arc cosine graph went from negative 1 to 1. And we talked about that up here. If you look at the arc sine graph, the domain is negative 1 to 1. Arc cosine, there's negative 1 to 1. And we will keep adding to this page in the next lesson as well when we talk about tangent, cotangent, cosecant, and secant. But for now, these are the domains that we've been working with so far. Now, let's talk about why these domains are important, why I had you list them. Let's start right here on E. So, when we're looking at these problems, the first thing you might think of is that arc cosine and cosine should cancel each other out because they're inverses, they're opposites. However, before we can cancel those out, we need to check that this angle is in the cosine domain. If it's not, we have to do some extra work. So, and by the way, I picked cosine domain because that's the one it's connected to. So, cosine domain is pi 6 in cosine's domain. Well, we just wrote down that the cosine domain goes from 0 to pi, quadrant 1 and quadrant 2. So let's graph. There's pi 6. That is in the quadrant 1 and quadrant 2 domain for cosine. So we say check, it is in the domain. If it's in the domain, these cancel, and our answer is just pi 6. So let's try that on G. Same thing. You would think that these should just cancel because they're opposites, but we have to check that this is in the domain of arc cosine. And I picked that because that's the one it's attached to. So the domain of arc cosine was negative 1 to 1. There's our domain for arc cosine. So I come back here, negative 3/5 is between negative 1 and positive 1. So check, it is in the domain. Because it's in the domain, those two things cancel, and our answer is just negative 3/5. Now, let's try an example where it doesn't work. So we'll start right here. We would think, hey, these should cancel because they're opposites, but we need to check that 11 pi 6 is in the domain of cosine. So here's, I know that the domain of cosine is 0 to pi, quadrant 1 and quadrant 2. 11 pi 6 is right there, which is not in the domain of cosine. So what we're going to do is be very clever here, because remember, for all the other problems we've drawn, there have been 2 triangles, and then we narrowed it down to the one that fit the domain. This just means that this 11 pi 6 triangle is the other triangle we would have gotten rid of that didn't work. There is another triangle that also works, so let's find it. We're looking at cosines here. So what other triangle has the same cosine or x value? Well, that would be this one right here. That triangle has the exact same x value. So these triangles share the same cosine value. This one's at pi 6. This one's at 11 pi 6. Now we already said this one doesn't work because it's not in the correct domain restriction. It's not in quadrant 1 or quadrant 2. However, pi 6 does. So that is our answer. They do cancel each other out. You just need to find the other triangle that fits your domain. So instead of 11 pi 6, I found this triangle at pi 6. It has the same cosine value, but pi 6 is in the cosine domain of quadrant 1 and quadrant 2. So that is what we're looking at when you have ones next to each other that will cancel. So you have like cosine, arc cosine next to each other, arc cosine, cosine next to each other, arc cosine next to each other. They cancel each other out if it's, in the domain. If it's not in the domain for the angles, then find the other triangle that is in the domain. Now, last one for this video. Let's talk about what we do when they're not matching. So this is sine of arc cosine. So those can't cancel each other out because they're different functions. This one's the sine function, that one's the arc cosine function. So there's no canceling here. Anytime you have two different functions next to each other, you're going to use the inside function to create a triangle and the outside function to answer. So here's what I mean by that. I'm going to use that inside function, that arc cosine is -3/5, to make a triangle. I know that cosine is x over r. So I'm going to go to an x value of -3, an r value of 5. X value of -3, r value of 5. And note that there are two triangles that fit this. X is -3, r is 5. Both of those two triangles fit. However, because this is an arc cosine, I stick to quadrant 1 and quadrant 2. So that one goes away, and this is the triangle I want. So I use the inside to build where this triangle goes. Now I can use Pythagorean theorem to solve for my last side, which is going to be y equals 4. Note that it's a positive 4 because it's in the second quadrant. If we were right here, it would have been a -4. So I've used Pythagorean theorem to completely build out my triangle. Now what I want to do is find sine of that triangle. I know sine is y over r. So I go to my y side is 4. My r side is 5. And that's my answer. So if the two trig functions don't match, use the inside one to build the triangle and put it in the right quadrant. Use the outside one to answer. So the outside one is our answer. We wanted sine, which is y over r. And that's how you do it if your trig functions don't match each other. Build the triangle and then answer. So with that is all for this video. We have one last video to do for this lesson, and then you're all done.